Hello, my name is Devashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solutions, and I welcome you all to this webinar. And today's topic is Cisco's policy-based routing. So, what about the routing? What are the different policies we use, and what is the traditional routing? And what is the special about this policy-based routing? How is it different from the traditional routing? All this and more we'll discuss here. So, let's begin. So we'll cover the key aspects of the Cisco's policy-based routing, including its definition, importance, and how it can effectively manage the network traffic, or can it do the traffic engineering? That also we'll cover here. So before discussing the policy-based routing, let's understand the traditional routing. What is the purpose of the router? That is the routing, means sending packet from one source to the destination. So in this traditional routing, router always does the destination based routing. That is the destination lookup. Means it always finds the route that is in the routing table of the router, and it always finds the path to the destination. It never looks the source network. So if it is there in the routing table, the destination network, it sends a packet. Otherwise, it cannot send the packet. But in case of PBR or the policy-based routing, it is reversed. So it is done on some policies. Say, if I want that the routing will be done based on the source address, that can be achieved with PBR, but you can never achieve with the traditional routing. So PBR is a technique used to make routing decisions based on policies set by the network admin. And this allows for finer control over network traffic by enabling different routing paths based on various factors such as the source address that I was talking about, application type, and other criteria. So if you are making the routing decisions over the source address, you can do it with this PBR. Now, what is the importance in network management of this PBR? PBR is crucial in complex networks where traffic needs to follow specific paths. So you want to follow a specific path. You want to route the traffic to the specific path. So you have to do the traffic engineering. For that, this PBR is needed. And to optimize performance or achieve particular outcomes such as load balancing, bandwidth management, all this, and maintaining serviceable agreements, SLAs. So for all these tasks, you have to opt for the PBR. Now it provides flexibility in directing the traffic in a specific way, and also it would suit the business policy and operational requirements of your organization. So you want to follow a specific route that you can do with this PBR or the policy-based routing. So that is the importance of the PBR. You are influencing the routing decision of the router. That is the importance. What is the comparison to traditional routing? Traditional routing relies primarily on the destination address. I've already told you to determine the best path. So it actually sees the RIB or the routing table, routing information base, and finds the best path, that is the destination network. Now, in contrast, policy-based routing evaluates multiple factors, allowing for more nuanced decision making. So PBR enables features such as traffic engineering or path selection, where traffic is routed based on source address or the application types, providing the enhanced control over routing behavior and policies. Now, how to configure it? To configure policy-based routing on Cisco devices, you have to follow these steps like define the access control list first, because see, you have to allow your LAN and you have to define it in the access control list. And it should specify the criteria for the traffic to be routed. Number two is create a route map that references the ACL and defines the actions to be taken, and such as routing to a specific next hop address. So you have to specify a specific next hop address. And number three, apply the route map to the appropriate interface or ingress or the egress traffic. But generally, we imply this route map on the ingress, that's the incoming interface, not the egress. Verify the configuration and monitor traffic flows. Now, this is about the theory part about the policy-based routing, what it is and how to configure. And actually, we should configure this policy-based routing hands-on. So for this, I am going to take you to the GNC console, and let me just switch on these routers and these PCs. So there you see. So you can go to any, say, the routers, and you can check the configuration. So the IP is already configured. So let the router boot. I can give this command as show IP interface brief, and you can see the IP address that is configured on this fast Ethernet ports. Also on the router 2, you can see the IP, and that is also the router 3, and also on the router 4. So here if you see the routing table of the R1, so OSPF you also configure. If you see the show IP protocols, so I am running the OSPF, that is a process ID 10 here. And if you see the RIB, show IP root, then you'll see that there is a OSPF root for the 20001 to the R3. And if I show you show IP root and to the 20001 that is connected to the R3, you see that 2002, that is the way to go, and 2002 that is the path here through this R4. It is selecting that because that is the 2002 on this interface. But if I want to do some traffic engineering, like I want to manipulate this route and I want the traffic to be shifted to this R2, so it will actually go through this R3 through this R2, not via R4. So in that case, you have to manipulate the path by the policy based routing. So how to achieve it? Say, first of all, you create a access list. Say access list 100, permit, then IP, then host. Say there is a host that is 10001, that is the PC connected to it, and you are reaching the host that is 20001, that is the loopback that is connected to the R3. So that is the ACL. Then you have to make a route map. So then route map, then say PBR 123 and then the permit 10, then the match IP address, say you are matching the access list, that is 100, then set IP next hop, then next hop. So there are two options. So you can set, say, default, and then you can give interface. So that is the default interface that you are specifying the interface that should be used by default to send the traffic. In that case, it is using the RIB, that is a routing information base. But if you are specifying IP next hop, means it is using the FIB, that is the forwarding information base, that we already know that the router copies the RIB, the routes from the RIB to the FIB. It is actually the direct copy. If the RIB is there, then the FIB should be there. So you have to actually set the set IP next hop, then you have to give this address 1002 this way. So you have to manipulate the traffic flow to the 1002, and then you have to you have to actually configure it on the ingress interface. That is the ingress interface of this router. It is, I think, it is interface F150, and IP policy route map, and you have to give the route map name as a PBR 123. So here you should put on this debug IP policy, and then if you ping, say if you ping the 20001 to the source would be the 10001. So definitely you will see that the ping is successful, and if you do the trace route, that is from the 10 20001, you see that it is still preferring the 2002, and if you give source, then this one. But if you are connecting, say, the different, say, PCs, so this PC, if you are connecting this PC, and if you are giving any IP address to this PC, so if the traffic is coming to the router, if the traffic is coming to the router, and then you can say this. I think this PC is having some trouble now, but we can actually stop it. We can delete the PC, and we can again take a PC, and we can connect it to it, and then again you can start this. Yes, and now let's see. Sometimes this GNS3 it gives some troubles with these PCs, because now you're I think getting this. But again it is not getting. So let me go to the router one. Let me save this, and again you have to just power off, and say again you disconnect this PC, and again you take a VPC, a fresh one, and again you start all the devices. Then you check the console of the VPC if it is starting. So the console is coming, but let me see. if it has this option, but it is maybe it is giving us some trouble because I think it's a pre-version. So anyway, you have to just reconnect these routers and see this R1, and if the traffic is coming from the PC, then only the policy based routing will work. Because if this R1 is, say for example, generating some routes and it is pinging the other router, so it will definitely not work. But yes, if the traffic is being redirected to the router, then definitely you can see that the policy based routing can be achieved. So one more thing we can do, say we can again stop this and we can take a router if this VPC is not behaving correctly. So what you can do, you can say take any other router here, you connect it to again to the 1 by 0, and then again you start all the devices, and this time you start the R5 console. So it is now booting, and you will give the 10001 IP here. Just reconnect the R3 also. We do not need other routers because it will consume a lot of RAM. That will be launched, and then we'll just give the IP address to the router R5, and then we'll ping. And then you'll see that if you give the debug IP policy, then you'll see the policy based routing that will give you the desired output. You see the IP here is 10001. So I think we have to change the ACL a bit. So here you have no access list, and the access list was 100. Permit IP host we gave as 10001 to the host 20001. So you have to again check the R3's interface also. If it is having the 20001, show IP interface brief, and it has no, I think it should have the look back. Yes, 20001 is there. So what you need to do, you need to go to the R5, and let's say I'm giving the IP address to its interface, say 10002, this one. So you have to say that ports IP here is 10001, and I have given the R5 IP as 10002. So you have to make the access list accordingly. Say access list 100 permit IP host is 10002, and it should connect to the destination host, that is 20001. And let me check the, I think the route map is there. So it is already configured. You can see the route map there. And if you just ping, say you give the debug IP policy, and if you ping the 20001, and I think here the router OSPF is not running. Yes, it is now pinging the gateway. Yes, it's pinging the 20001 now, you can see. And yes, now you see the IP policy, the PBR is working. So you can see that the FIB policy match, and the destination is 20001, source is 10002, and you can see that it is showing FIB policy routed. This FIB policy match and the PBR counted means that if the traffic is coming from the source, that is the 10002, and if it is directed to the 20001, then the router is following the FIB, not the RIB. And if this router R1 does the ping to the 20001, there is a normal one. If it is pinging, and can you see that debugging is happening? No debugging, because here the router is actually taking the RIB. But here in case of the PBR, if it is coming from the 10002, only then the policy based routing is getting activated, and there the FIB or the forwarding information base is used. So that is the way you configure the policy based routing. So I hope that you have got the immense understanding of this policy-based routing. That is a very important feature and topic for your CCNP NRC, as well as it is in the ENCORE studies. So it may not be directly in the CCNA level, but also you can study it for gaining the higher knowledge about the CCNA level also. So I hope that it will helpful in your future studies also, and it will be very helpful for your job prospects as well as a Cisco network administrator. So I thank you all again for watching and joining this webinar, and I will come with some new topic next time. Till then, keep studying and bye.